Hey, welcome back. This is the final exam review for College Algebra Math 1530. So I'm going to go over the types of problems I anticipate putting on the test and give you sections that I think are going to be on the test. And the test will be in my math lab, and I'll proctor it in WebEx. And I'll put the day of the exam on Blackboard, so you'll know it'll be during class time that we usually meet. Okay, so I'll post that on Blackboard. You'll know if you read Blackboard. Anyways, the first section that will be on the exam will be, and this is a comprehensive exam, so we'll go all the way back to P.7, which was on equations, believe it or not. In particular, I want to look at the rational equations like 17 to 25. Okay. So as you go through and review, you have two options. You can use the book and just pick out problems from 17 to 25, or you can go into my math lab here, which I have just popped up on the screen, and hit homework P7, and then open it up. This number right here tells you the number of the problem that's in the book. So this is P7, number 17, and you could do it that way, right? So there's two parts of this problem. You get the first, identify the restrictions, and then you can go ahead and solve it. So let me copy it down on my paper. Let's move this to the side so you can see. And of course, I don't have enough room. Put that over there. Okay, so 17. 1 all over x minus 2 plus 4 equals 13 all over x minus 2. Okay, so to get the restriction, you're just taking the denominators and setting them equal to 0 and seeing the bad place. So I see one denominator is x minus 2. Well, they're both x minus 2, right? Set that equal to 0, solve, and that's your restricted value. So what are the values? The variable makes the denominator 0. That's what they're looking for there. 2. Push enter. Yay. Okay. And now they want to know the actual answers. So to get the answer in these kind of problems, you have to multiply both sides to get rid of the denominator, all of the denominators. There's only one real denominator here, the x minus 2 thing, so I'm going to multiply both sides by x minus 2. Right. So on the right side, I have to distribute. So here I'll get 1 plus 4 times x minus 2. On the right side, the x minus 2's cancel, so you just get 13. And the result is a linear equation and one unknown, which I know how to solve. Okay, so first, simplify by distributing. Combine like terms for x minus 7. Then isolate the variable, plus 7, so 4x is 20. And then, isolate the variable still. So 4x is 5. Make sure that's not restricted. Okay, x equals 5 is good. It's not 2. So that will be your answer. The solution set. Make sure you read the directions. Type an integer or simplified fraction. Use comma to separate answers. There's only one answer. So 5. Yay, good job. Okay, get the idea. Let's do one more of those, see if there's another one that's even vaguely interesting. Let's try 9. Is that still in our range? Yeah. No, sorry, I went out of the range. Let's try 7. See if that's good. Oh, yeah. Okay, so that's another one of these. So that's 25. Let's see how it goes. So 1 over x minus 3 minus 5 all over x plus 5 equals 8 all over x squared plus 2x minus 15. All right, so get the restrictions. So clearly x minus 3 gives you 3. X plus 5, the other denominator, gives you negative 5. And then factor that last guy, x squared plus 2x minus 15, setting it equals 0. Factor it. Minus 3. 0. Oh, and we're going to get the same answers from that, so I don't need to bother with that. Okay. So by restrictions 3 and -5, make sure you read the directions. You have to separate these by a comma. -5. Okay. Where's the stupid button? Check answer, I guess. Okay. And then they want the solution set. If there's more than one answer, you need to put them all in there, separated by commas. Okay, so I'm multiplying both sides to get rid of that crummy, get rid of the crummy fractions, right? They help a little bit to go ahead and factor this denominator. Make clear what you're doing. And then I'm going to multiply both sides to get rid of the fractions. I need to get rid of an x minus 3. I need to get rid of an x plus 5. So if I do it to one side, I have to do it to the other. Okay. On the right side, on the first distribution, the x minus 3's cancel. And you have 1 times x plus 5, which is just x plus 5. Second distribution, the x plus 5's cancel. And you'll have -5 times x minus 3. On the right-hand side, everything cancels, and you're just getting 8. Okay, so we have x plus 5, distribute the -5, minus 5x plus 15 equals 8. Combine my terms, -4x plus 20 equals 8. Move the 20 to the other side, I give you about -12, right? And then you're ending up with x equaling, drumroll please, 3, which is bad news, right? Because 3 is one of our restricted values. So that was the only potential solution. So then our answer must be no solutions. So you can zip over here. The solution set is the null set. That's the same as saying there's no solutions. And then we'll check our answer. Yay. Okay. Okay. Good stuff. So what else? Let's move on to P9 now. So P9 was all about inequalities, absolute value inequalities in particular. So I'll be looking at those, 57 to 91. The main idea was that if you had something like x minus 2 less than or equal to 5, you could rewrite that as a compound inequality and then solve it. Okay. The other case, maybe you had x plus 3 greater than or equal to, let's say, 8. Then in that case, you would go x plus 3 less than -8, or x plus 3 greater than 8, and you would solve those two inequalities. So there's really only two types of problems here. This first type, and it's all determined by the direction of the inequality. Hard part is sometimes in the problem, they'll kind of try to mix everything up, and you have to rearrange it to put it in one of these forms to figure out how to solve it. Okay, let's go to P9 and see how that goes. There's P9. And we want problems like 57 to 91. So let's get in here. So this will do. Okay. I minimize this, push this to the side, and take a look. So it's number 73. We have the absolute value of 3x plus 9 all over 8 greater than or equal to 6. Right, so it's already in our form, the second form, so that's great. We can just go ahead and rewrite it as two inequalities. 8 less than or equal to -6, and then 3x plus 9 over 8 greater than or equal to +6, and then solve each inequality. All right, so 3x plus 9 less than or equal to -48. Subtract 9 from both sides, -57. Divide both sides by 3. Be careful if you divide and multiply by a negative, you have to change the direction of the inequality. Thankfully here we don't have to do that. 57 divided by 3. 1, 3. My calculator is broke. 19. 19. I may have to whip out the computer calculator eventually. Anyways, 3x plus 9. On the test, you're only allowed to use scientific calculators. 48. 3x greater than or equal to 39-ish. And then x greater than or equal to 13. You need to give your answers in interval notation. So if you've forgotten how to, you draw a number line. Here is negative 19. It says everything less than or equal to negative 19, so that stuff. And then everything greater than or equal to 13. You'll have to use a union symbol to symbolize the solution set. Negative infinity to negative 19, bracket union with 13 to infinity. Okay, so let's go over here and try to plop that into this computer deal. So I have to get us the union symbol. Don't use a U, use the union symbol. But you know that from doing homework, right? So negative inf t, I think it's just inf t. It's not letting me do it. So I just write negative and then use a symbol. To negative 19, then use bracket. Oops, wrong kind of bracket. And then use the union symbol, and then bracket. And then 13 to, maybe you have to use backslash and inf t. That's still not letting me do it. Usually if you hover over these things, it'll give you the, yeah, backslash inf. There it is. Okay. And then in parentheses, and then check your answer, and hope it's right. Yay. Okay, so you have no interval notation. Let's not do another one of like that. Let's do something else. That was 24. So let's try, see if 26 is any good. Sure. All right. So let's try this guy. So this is one of those ones, it's not in the appropriate form yet. This is number 79. So we're going to have to work a little bit with it. Just like some of your co-workers, you know, you have to work with them. Negative 54 over here. Okay, so I'm going to divide both sides by negative 9. And of course, if you divide or multiply by a negative, it changes the direction of the inequality, right? And then that'll be 6. And then this is the first type of inequality, and it'll turn into a compound inequality, x minus 2 less than or equal to 6, greater than or equal to negative 6. Add 2 to all three sides, so negative 4 less than or equal to x less than or equal to 8. And that's your answer. I mean, it's right there. In interval notation, it's just everything in between and including negative 4 and 8. Okay, so let's zip over here, plop that in. Oh, let me make sure I'm recording my voice. Yes, okay, it's recording my voice. You never know. Nothing worse than doing an hour-long video and having to run back and do it again because you didn't put the mic on. Anyways, there's that. Let's check our answer, and then hopefully it's right, and we can move on. Yay. Okay, so that's P9 stuff. Chapter 1 was kind of first began with an introduction to graphing. Okay, I presume everybody knows how to plot points at this point. And we'll go ahead and go into 1.2. Okay, I just woke up. My voice is still adjusting to reality. 1.2. Yeah. And we're going to want questions like, so here, 2 questions like 27 to 37. I'm sort of looking at my book at the same time as well. I believe these are ones where you just are plugging stuff into functions and simplifying them. There's a lot of good stuff in this section. Identifying domain and ranges from graphs. I love those problems, but I think this stuff is a little bit more important. So let's go ahead and go to the problem set and see if we can find any. Okay, so this is Yeah, so this is number 37, as a matter of fact. Let's go ahead and take a look at that guy. If it can let me drag this apart. There you go. Thank you. Thank you, Mr. Webdesign. Okay, these are evaluating the function type problems. So 37, evaluate the function, just disappeared on me. F of x equals x over absolute value of x at the given values of the independent variables, and then simplify. Okay, so f of part A, f of 1. So you plug in 1 wherever you see x, and then simplify. Okay, so it's 1. The absolute value of 1, that is a 1, I just butchered it, is 1. 1 over 1 is 1. Okay. 1. Yay. Let's try negative 1. So f of negative 1 is negative 1 all over the absolute value of negative 1. That will be negative 1 over now positive 1. And of course, a negative by a positive is negative. So that would just be negative 1. Negative 1. Yay. Part C, we want f of r squared. This one. Just plug in r squared where we see an x. And believe it or not, the r squared, anything that's squared will always be greater than or equal to 0. Okay. Of course, we want to avoid 0 for r. It doesn't say anything about that. But assuming that the r is not 0, r squared will be positive. And when you take the absolute value of a number that's positive, like positive 5, you just get back the number. So if we took the absolute value of r squared, we should just get back r squared. So presuming, again, that r is not 0, we will get 1 as our answer. Yay. Okay, let's get some other ones. See if there's anything else worth looking at. What did we just do, number 10? Let's try number 7. No, I'm sick of doing absolute values. Let's try number 5. That's not one in our set. Let's try number 8. Okay, I'm all for that one. So this is number 29 in the book. My function this time, f of x is x squared plus 3x plus 5. Part A, what is f of 7? Okay, so if I plug in 7 wherever I see x, I get 49 plus 21 plus 5. And 21, 0, 1, 4, 5, 6, 7. Add a 5, so I get 75. Let's try that guy, 75. Yay. F of x plus 8. So this time I'm plugging x plus 8 into wherever I see x. I have some foiling on the first part. So x plus 8 squared is the same as x plus 8 times x plus 8, which will be x squared, plus 8x plus 8x is 16x, plus 64. Then I distribute, plus 3x, plus 24, and then plus 5. And then you have to simplify. So what do we got? X squared plus 16x plus 3 is 19x, 64, 24 gives me an 8, 6, 7, 8, and then a 5, 8, 9, 10, 11, 12, 13, carry the 1, 93, so press 93. Plug that in. X squared plus 19x plus 93. And then f of negative x. You plug in negative x where we see x squared, x in the expression. So you get negative x squared plus 3 times negative x plus 5. Notice the use of my parentheses. That reminds me that when I square the negative x, it includes the negative. So negative x times negative x is positive x squared. And then 3 times negative x is negative 3x. plus 5. And that'd be my answer. 3x, whoops, minus 3x plus 5. Yay. Okay, let's move out of there into 1.3. So 1.3 had a lot of stuff on apparently domain and ranges. It had piecewise functions, but it also had this thing called the difference quotient. Okay, the difference quotient is important later on in math. It represents slope. So a lot of mathematics is all about just rates of change. Rates of change are everywhere, right? You think about the rate of change of people infected by the coronavirus and things like that. We can use those ideas to model pandemics and things like that. So slope, very important. That's why I want to put it on our test. So, you know, the question should give you the difference quotient. That was this thing, if you remember. And your goal was to simplify the heck out of it. Okay, so this is now 1.3. And I'll be looking at problems like 71 to 85. Okay, I'll just take one from the book. Let's look at 77. Okay. So we have f of x equals x squared minus 4x plus 3. And we're doing this, and note what the difference quotient looks like a slope formula, right? It looks like y2 minus y1 all over x2 minus x1. So it's kind of, it's not quite, there's still questions, you know, what the heck, it's just got an h in the bottom. But it turns out the h is like a change in x, okay? It's like a difference between two x values. It is basically a slope, but now for a function that has all kinds of curves in it. Okay, so the idea is for lines, you know, you have slope is a constant rate of change for the equation of a line, but for something that has curves all over the place, it's not quite apparent what the slope, quote unquote, slope would be. So what they do is kind of attach little tangent lines that measure the slope at particular points. Like right here, the slope would be positive, and then in here the slope would be negative because the tangent line's going down. Okay, and then they use that formula to get the slopes. Okay, so that's the hopefully some motivation. Okay, so let's take a look. I need to find f of x plus h minus f of x all over h. Okay, so what you're going to do is, for the first one, you're putting x plus h in wherever you see x into this formula. Okay, so it's going to go there and there. All right, so let's do that. So I have x plus h squared. So I have to do some foiling. Minus 4 times x plus h, and then plus 3. Okay, so that's just from the first part. Then you go minus f of x, and you just plug f of x in there. Okay. And then that'll be all over h. So you get a little bit of algebra. They say calculus is 90% algebra and like 10% infinity. Okay. Okay, so first I need the FOIL this guy. That'll be x squared plus xh plus xh, which will give me 2 xh's, and then plus h squared. And then I need to distribute. So minus 4x minus 4h plus 3. And then I need to distribute again. Minus x squared plus 4x minus 3. And that'll be all over h. Combine like terms, x squared minus x squared is 0. There's no more 2. I got 1 2xh. I got 1h squared. The 4 x's cancel. So you should have some cancellation going on. If you don't, then something is wrong. All over h. Each term in the numerator has a factor of h, so you can factor that out. You get 2x plus h minus 4 all over h. And then you could cancel out the h's, and you're just left with 2x plus h minus 4, and that's the answer. Okay. Okay, so that was 1.3, sorry. Let's look at 1.4. So 1.4, we had all kinds of stuff on slope and equations of lines. So this section was more of a review, hopefully. Look at problems like 11 to 30, 11 to 37. No, sorry, 1.4. Yeah, 11 to 37. So these are problems where they give you information and you have to figure out the equation of a line from the given information. So you need to have memorized your slope formula. So if you have 2 points, the slope is y2 minus y1 over x2 minus x1. You also need the point slope formula for the equation of a line. Y minus y1 equals m times x minus x1. So get that memorized. And let's take a look at some of the types of problems. So there's basically two types. Let's look at the hard type. Okay, so the first type, they give you a slope and a point, and basically you just plop it into a point slope form there and figure it out. The other type, they give you 2 points, and you have to kind of do everything. So 29, they give you a point -3, -1, and 2, 4. Okay? So first, you need to get to equate the equation of a line, you need a slope and a point. You got 2 points, good, but you still need a slope. All right, so slope, y2 minus y1, 4 minus -1, all over x2 minus x1, so 2 minus -3. So b4 plus 1, all over 2 plus 3, which is 5, all over 5. Oh, they were nice to us there. And then we need to plop everything into our formula, point slope formula. So I'll pick either a point. I'll just take the first point I see. So -1 equals 1 times x minus -3. And then I'm going to put it into whatever form they ask for. The book is asking for slope intercept. So you need y equals mx plus b. So you got y plus 1 equals 1 times x plus 3. And you distribute the 1. Of course, you get x plus 3. And then move the 1 over. And you get your equation in the appropriate form. Okay. Okay, so that is 1.4. I'm not going to include 1.5, 1.6, 1.7. There was a lot of stuff more stuff on slopes. So just remember the slope of perpendicular lines have negative reciprocals. 1.6 was on transformations of functions. So that was just shifting it around in the plane, doing horizontal shifts, reflections, stretch shrinks, and then vertical shifts. 1.7 was on compositions of functions. We're going to skip out of that because that's only useful for 1.8 when we're checking inverse functions. So 1.8 then, back on track, problems like 11 to 27, where we're finding the inverses of functions. So let's dive back into my math lab and see what kind of problems those are. So where are we? 1.8 now. And I'm looking for questions like 11 to 27. Okay, that's 29, so new. Is that 15? 15. Let's look at 11, I guess. Okay, is this one of those? This is 21. Do I want 21? Yeah, okay. Right, so this problem, they want you to find they're telling you it's 1-to-1, and they want you to find the inverse for it. So for these types of problems, all you have to do is kind of let x equal y. So here is the original function. What you need to do is swap the x and the y. So here you have x, on the other side you'll have y, and then solve for y. Okay, so you can basically multiply both sides by y. You get y x equals 4, and then divide both sides by x, assuming x is not 0, and they tell you that there. So in this case, the inverse is exactly the same as the original, 4 divided by x. let's get another one. Oh yeah, so this one is kind of nasty. Problem 25. We'll do a similar question to it. Okay. Verify that the thing has an inverse function. Oh, it says it has an inverse. It says it's 1-to-1. Find the equation for f inverse then. Okay, so again, that's just a matter of swapping the variables and solving for the other one. So in this case, y equals x plus 16 all over x minus 4. So swap the variables. X equals y plus 16 all over y minus 4. Multiply both sides by y minus 4. You get xy minus 4x. If I distribute, equals y plus 16. I want to get all the y material on one side. So I'll have xy minus y equals 4x plus 16. Factor out the y, you get x minus 1 equals 4x plus 16. Divide both sides by x minus 1, and you get y equals 4x plus 16 all over x minus 1. Okay, and then get this thing moved over. And of course x can't be equal to 1 because of the denominator. If I can get this thing to move, that would be awesome. Okay, well, it's not going to move. Let's do that then. 4x plus 16 all over x minus 1, and clearly x cannot equal 1. Okay, so that's the first part apparently. Check answer. Yay. Verify the equation is correct. So basically all you have to do is kind of just put the original equation in there. Well, in this case you have to put 4x plus 16 all over x minus 1 in there. It's going to let me copy. No, of course not. Okay, so 4x plus 16. X plus 16 all over x minus 1. And then if you put that in there, it should equal x, okay, basically. You can do that yourself, or you just kind of, I don't have time to bother, so I'm just going to put x in there. 16 all over x minus 4. Oh. So backslash x plus 16 all over x minus 4, and eventually that will just equal x. And what else? The equation is verified. Final check. Yay. Okay, so stuff like that. Here's another problem like that. Okay, so I think that's pretty much what you're up against for that section. All right, so let's mosey on to chapter 2. Okay, the beginning of chapter 2 is graphing. Maybe I said that. No, the beginning of chapter 2 is the complex numbers. I'm not going to put the complex stuff on here. I'm just going to start out in 2.2. And in 2.2, we have problems like 27 to 37 to worry about. And these are all quadratic equations. And I'm interested in the form, the ax squared plus bx plus c form, not necessarily the vertex form, or you can read the vertex off of it. So in particular, I care about the types where f of x equals ax squared plus bx plus c, and then graphing these. Okay, so you know, how would that work? First, you kind of look at the leading coefficient. If a is greater than 0, it's concave up. If a is less than 0, it's a sad face. From there, you get the vertex. Okay, and this, you will have to memorize those formulas again. So negative b all over 2a, comma f of negative b all over 2a. Okay. And usually the vertex is given in the form h comma k. Okay, and so that'll be that. 3, what do we do? The axis symmetry. That will just be where x is equal to the h coordinate of the vertex. So it'd be negative b over 2a, or if you'd rather h. The domain and range. The domain is always negative infinity to infinity. And then the range is going to be depending on the type, right? So if it's concave up, it'll start at the y coordinate of the vertex and go to infinity. If it's concave down, it'll go from negative infinity to the y coordinate of the vertex. Okay. And then you get your x and y intercepts. The x-intercept, you let y equal 0. So 0 equals ax squared plus bx plus c. For the y-intercept, then it's letting x equal 0. So y will equal c. So the y-intercept is always just 0 comma c. Okay. I think that was all we are always asked to do for these problems. Let's go into my math lab and see how those problems go. So this is now section 2.2, problems like 27 to 37. So let's go in there and take a look. 2.2. Take a look. 27 to 37. Yeah. Okay, so this is one of those. So in this problem, they want us to use the vertex intercepts to graph the quadratic, give the equation of the axis symmetry, use the graph to determine the range, and all that jazz. Okay, so pretty much just everything I went through. Right, so in this case, f of x equals 2x minus x squared plus 3. So first, you may want to rewrite it. Negative x squared plus 2x plus 3. It's going to be concave down because the a value is negative 1, which is less than 0. Okay, so sad face. Then the vertex is going to be negative b over 2a. So negative 2 all over 2 times negative 1 is negative 2 over negative 2, which is 1. And then for the y coordinate, so the x coordinate is 1. For the y coordinate, you just plug 1 back into the equation. So you get negative 1 squared, which is 1, plus 2 times 1, plus 3. So you get negative 1 plus 2 plus 3. 3 plus 2 is 5, minus 1 is 4. So the vertex is 1, 4. The axis symmetry then is going to be x equals 1, and then the domain, of course, negative infinity to infinity, and then the range, because of the concavity, is going to go from negative infinity to the y-coordinate of the vertex, and you include that, and then x-intercepts, so set it equal to 0. Negative x squared plus 2x plus 3 equals 0. And I'll multiply both sides by negative. Minus 2x minus 3 is 0. Sometimes you have to use a quadratic. I think we're going to get lucky in this case, though. So x, I believe, minus 3, x plus 1. So x equals 3, x equals negative 1. And then finally, the y-intercept is just going to be 0, 3. Okay. All right, so let's go in here and see what they need us to do. Click the graphing tool to graph the equation, and it wants us to use the vertex and one intercept. So the vertex, we said, was at 1, 4. So 1, 2, 3, 4. And then, whoops, I used the wrong type. So it's at 1 and then 4. And then, I guess 0, 4, right? For the, well, that can't be right. 0, 3. It's a sad face. And there it is. Okay, so save. That's easy. What else? Axis of symmetry. I wrote that in there somewhere. X equals 1. Make sure you type an equation. Excellent. Domain, of course, negative backslash inf to backslash inf. And the range, negative backslash inf to 4. And then, oops, that's it. Okay, so one like that. Parabolas kind of never go away. All right, so that's 2.2. 2.3 was on polynomials and graphing those things. Let's skip that section and go into 2.4. So 2.4 was on long division. I don't really care about synthetic division. It's only useful for finding roots of polynomials, which I'm going to kind of skip out on. Anyways, 2.4, 1 to 31 odd. I don't know. Let's look at number 20, I guess, or maybe even. I'm just looking in the book here, 1 to 31. Let's look at, make sure it's vaguely interesting. I guess number, I don't know, number 11. Okay, this will be interesting because it needs placeholders. So 4x to the 4th minus 4x squared plus 6x divided by x minus 4. Okay, so inside my division bar here, I have 4x to the 4th, and I'm going to put placeholders in so everything lines up. 0x cubes minus 4x squared plus 6x plus 0. On the outside, it's just x minus 4. Okay, so you ask yourself, what times x is 4x to the 4th? 4x cubed. Okay, so 4. Then I have to multiply all of it. I have to distribute that, right? So in my brain, I'm going 4x cubed times x minus 4 and distributing. Okay, so I write 4x to the 4th minus 16x cubed. And then I subtract the entire thing, not just part of it. Okay, so 4x to the 4th is 0. 0x cubed plus 16x cubed, 16x cubed. Bring down the next term. Okay, so plus what times x is 16x cubed? That was 16x squared, apparently. So I have 16x cubed. In my brain, I have to distribute. Minus, apparently, 64x squared. And then I subtract the entire thing. We'll get 60x squared resulting. Bring down the next term. And so what times x is 60x squared? That will be plus 60 x. Okay. So I'll have 60x times x is 60x squared, and then minus apparently 240x. Then I have to subtract the entire thing. This will give me positive 246x, and then plus 0. So what times x is 246x? That'll be plus 246. And so 246x minus 246 times 4. 4 carry 2, 16, 17, 18, carry the 1, 8, 9, 84. And I have to subtract this thing. Okay, so it'll become 984 as my remainder. So the entire answer would be equals 4x cubed plus 16x squared plus 60x plus 246 plus, and then this other stuff is a fraction, right? It's always going to go plus the 984 all over x minus 4. Okay, plus 984 all over x minus 4. Okay, so expect some long division. That's 2.4. 2.5 is finding zeros of polynomials. We're going to skip that and go into 2.6. problems like 21 to 43. And these were graphing rational functions. I'm not going to have you go through the whole rigmarole. You're going to do it again in calculus if you get to calculus. These types of problems are just in finding vertical asymptotes and horizontal asymptotes. Okay. Okay, so the vertical asymptotes are found by setting the denominator equal to 0. And then solving. Okay, it's basically restricted values, and then you'll get x equals something for your answer. Okay, so for example, let's look at, I don't know, 31. We have the rational function g of x equals x minus 3 all over x squared minus 9. Okay, so all you have to do is take the denominator, set it equal to 0. And you get x squared equals 9. The square root property then, x equals plus or minus square root of 9, which is 3. So you got two asymptotes. And you just borrow the x equals, okay? X equals negative 3 is one, and then x equals positive 3 is the other. And those will be your two answers, okay? Then finding horizontal asymptotes, which is basically the end behavior of the graph, that was determined by the degree of the numerator and denominator. Okay, so if the numerator's degree is less than the denominator's degree, so for example, if you have like number 37, you have 12x, all over 3x squared plus 1. The horizontal asymptote, which will be y equals, will be 0, because the degree of the numerator, which is 1, is less than the degree of the denominator, which is 2. Okay, so that's the first case. Second case is when they have the same degree. Okay, so like number 43, f of x equals negative 2x plus 1 all over 3x plus 5. In that case, you could just take the leading coefficients of the high degree terms. So in the top, the negative 2x is the high degree term, so you just borrow the negative 2. And the denominator, the 3x is the high degree term, so you borrow the 3. And then your horizontal asymptote will be negative 2/3. Okay. And then the other case is when the numerator's degree is greater than the denominator's degree. And in that case, you're not going to have a horizontal asymptote. Okay, so 41 is that type. So h of x equals 12x cubed all over 3x squared plus 1. In fact, in these cases, you have a slant asymptote, but we're not going to worry about that. No horizontal asymptote. This idea does become important later on in math, so I want to make sure that we include that in our topics for the final. Okay. So that's 2.6. Then we're just going to jump out of chapter 2 into chapter 3, which is all about exponentials and stuff like that. Okay, so we'll begin with 3.2, which is basically, can you evaluate logarithms? And so we're looking at problems like 21 to 41 odd, and then 81 to 99 odd. Okay, so 3.2. Let's take a look at some of those from the book. 3.2. For example, number 27. Okay, so these are just evaluate the log. So log base 2 of 1/8. Okay, so how did these things work? You're asking yourself 2 to what power equals 1/8. Okay, so you can, rewrite the other side if you wish. This is the same as 1/2 cubed, and then that's the same as 2 to the negative 3. So the answer is negative 3. Okay. How about 31? Log base 2 of 1/√2. So if you see a fraction, it usually means there's a negative involved. Anyways, 2 to some power equals 1 over root 2. Root 2 is the same as 2 to the 1/2. And then you can rewrite that as 2 to the negative 1/2. So the answer is negative 1/2. So problems like that. Also have to know how to do the natural log. So problems like 87. Remember, the natural log of x is the same as log base e of x. Let's look at 87. So the natural log of 1. Okay, so it's the same as asking e to what power equals 1. And of course, it's just 0. Let's try, I don't know, ln, number 91. ln of 1 all over e to the 6. Okay, so that's, you're asking e to what power equals 1 over e to the 6, right? So that's the same, 1 over e to the 6 is the same as e to the negative 6, so it's just negative 6. Okay, so can you evaluate logarithms? That will be 3.2, then 3.3, we get into the properties of logarithms, looking at questions like 21 to 41 odd. Whoops, no, just 1 to 69 odd. 1 to 69 odd. And these are the types of problems where you're using so if you had the log of m times n, that's the same as the log of m plus the log of n. If you have log of m divided by n, so as long as n is not 0, you have the log of m minus the log of n. And then if you have log of m to the p, that's equal to p log m. So you have to have those rules embedded in your brain. Let's go ahead and look at 1 or 2 of those. So let's look at 31. And these problems are expanding the logarithm. So here we have log of the cube root of x over y. Okay. So we could rewrite that as the log of, well, there's a couple ways you could do it. First, you can rewrite it to a 1/3 power and then use the power rule. And then you could use the quotient rule on the log of x over y. So that'd be log of x minus log of y. And then distribute the 1/3. So get 1/3 log x minus 1/3 log y. And then that'd be it. Okay. Let's look at one where we're condensing. Let's look at 65. Whoops, did I go too far with those problems? 69. Okay, so there's a hard one. 65. We have 1/2 of log base 5 of x plus log base 5 of y minus 2 log base 5 of x plus 1. And I want to write that as 1 log. There's never a Kleenex when you need it. Okay, so first I'm going to condense inside the parentheses, so I get log base 5 of x times y. Here, if you wish, you could bring the 2 inside the log. Okay, so this would be log base 5 of x plus 1 squared. Then you could bring the 1/2 inside this log, so you would have log base 5, and be sure to apply the 1/2 power to both the x and the y. It's whatever's inside the log. And then, minus the log base 5 of x plus 1 squared. And then you can combine those two using the quotient rule. So log base 5 of xy to the 1/2 all over x plus 1 squared. And if you wish, you can rewrite the 1/2 power with a square root. But I don't think that's necessary. Okay, so there's expanding and condensing logarithms in section 3.3. Then section 3.4. We're going to be, what are we going to be doing? Log and exponential equations. So looking at problems, basically anything goes 1 to 91 odd. And the exponentials, there's two ways to solve exponentials: equate the bases or take the logarithm on both sides. Log equations, you have to remind yourself to check your answer at the end, because sometimes that will change the answer. So anyways, let's look at one of each. So for example, number 13. This is an exponential equation. 3 to the 1 minus x equals 1 over 27. So the idea with these is to equate the bases on both sides and then equate the exponents. Okay? So this is 1 over 27 is 1 over 3 to the third. Then I can write 3 to the 1 minus x equals 3 to the negative 3. And then you can equate the exponents. Solve for x, and x is 4. Okay. The other type of problem was when you have to take the logarithm on both sides. I won't be including anything like 43 to 48. So omit 43 to 48. Those kinds won't be in there. But the other kinds are fair game. So for example, 35, e to the 5x minus 3 minus 2 equals 10476. So first you want to isolate the exponential part. So move the 2 over, 10478, and then take the logarithm on both sides. Okay. And then use a power rule, or just note that m1 and e are inverses, so they'll cancel each other out, and that'll become 5x minus 3. Isolate the variable term. Divide both sides by 5. Okay, and if they call for a decimal approximation, of course, get that. This one wants 2 decimal places. My calculator is currently in the shop, so I'll leave that to you. Okay. So those are exponential types. Then the logarithm types, again, there's 2 versions. There's ones where you're using the definition of the log, which basically says if you have log base, I don't know, 3 of x plus 2 equals 5, you could rewrite that as 3 to the 5th equals x plus 2. Okay, and then solve that. So let's look at one of those. I guess let's look at number 69. So we have log base 3 of x plus 6 plus log base 3 of x plus 4 equals 1. Okay, so I'm first going to combine the 2 logs together using the product rule. So you'll have x plus 6 times x plus 4 inside the log. Then you use the definition of logs. So 3 to the first power equals x plus 6 times x plus 4. Okay. And then on the right-hand side, you'll have foiling, x squared plus 10x plus 24. And then move the 3 to the other side, so you have 0 equals x squared plus 10x plus 21. And then factor it, x plus 7, x plus 3. And then you have 2 answers that are potential answers, but may not both work, -7, -3. You have to plug them into the original equation, -7 plus 6. As soon as you get a negative resulting inside of a log, you're done. Like that would be log base 3 of -1. That's bad news. X equals -7 won't work. Okay. Okay. So try x is -3. Base 3, -3 plus 6 plus log base 3, -3 plus 4 plus 1. Simplify. So this one's working. 3 plus log base 3 of 1 is 1. Log base 3 of 3 is 1. Log base 3 of 1 is 0. That one works. So your only answer then is -3. The other type is when you equate the sort of the guts of the logs. So like number 83, we have log of x plus 4 minus log of 2 equals log of 5x plus 1. Okay, so here I have log of x plus 4 all over 2 equals log of 5x plus 1. If it's in this form, then you could just equate the insides of the logs. Okay, so you get x plus 4 over 2 equals 5x plus 1. Multiply both sides by 2, so you get x plus 4 equals 10x plus 2. And then you could solve for x. So you get 9x equals apparently 2, and then x equals 2/9. Makes me think I got something wrong there. 2x plus 1, 10x plus 2, 9, 2. Yeah, it's got to be right. Okay, and then just make sure it works. Let's look at it works. Log of 2/9 plus 4. 4 is the same as 36/9. Just write it like that. Minus log of 2 equals log of 10/9 plus 9/9. This will be log of 36, 37, 30, 38/9 minus log of 2 will be the same as dividing this by 2, which is the same as multiplying by 1/2. Over here I have log of 19/9, and then I have log of 19/9 equals log of 19, and that one works. Okay, so your answer 2/9, great. Okay, so that's log equations, and okay. From there, we had chapter 7. We just did chapter 7 test material, so I think we're good with chapter 7. Okay, so there were systems of equations, systems 3 equations, partial fractions, nonlinear systems, all great stuff. Systems of inequalities. Let's just go ahead and skip into chapter 8. 8.1 and 8.2, the probability of you ever using that stuff again is very small. Unless you're going to become an engineer or something like that, you'll probably never see that again. So I'm going to skip that material. Just give it for homework. And then fast forward, then we're into 9.1. Okay, so 9.1, I just want you to be able to graph simple ellipses, so problems like 37 to 49. So let's take a look. Okay, let's look at number 43. Okay. So I have x squared over 25 plus y minus 2 squared over 36 equals 1. So get the center. This looks like it's 0, 2. And then you need your ABC values. So A is the bigger number. Okay, so you may think A is 5. It's not. It's a 6 because 36 is bigger than 25. That also tells you the orientation is going to be with the major axis parallel to the y-axis. Okay. B value then will be 5, and C, you should have that in your formula sheet, will be 36 minus 25, which is the square root of, I think that's just, are we lucky to get 9? No, 11. Ugh. I have to open my calculator. Let's make sure that's right. Sometimes my brain plays tricks on me this early in the morning. 3.32-ish. Okay. So 3.32-ish. Right, so you can go ahead and get your vertices if you want. So the vertices, you're going to be going up and down to get them by A. So you're manipulating the y coordinate. So it'll be 2 plus or minus 6. The foci, you're going up and down by root 11, so 2 plus or minus root 11. And then your the vertices on the minor axis, I don't know what to call those, call them VM, you're going left and right by 5, so plus or minus 0, plus or minus 5, comma 2. Okay. And then we can graph it, 0, 1, 2. Okay, so I'm going up and down by 6 to get to the vertices. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then I'm going left and right by 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. And then I'm getting my vertices left and right by 3.32. 1, 2, 3, 0.32. 1, 2, 3, 0.32. And that should do it. That should do it for the picture. Okay. So being able to graph those guys, 9.2, then I need you to be able to graph hyperbolas, just simple hyperbolas, problems, like 33 to 41. Let's go ahead and look online to my math lab and see what they're tasking us with in this very important section. So 9.2. Someday I will be able to move this around. Homework 9.2. Here's 9.2, getting towards the end here. Okay, I said problems like 33. Okay, so not that. Okay, here's problem 33. Let's try a problem. 19. Let's try 19, see if that's any different. Okay, so let's try this guy. Okay, so I have y plus 3 squared all over 16 minus x minus 3 squared all over 25 equals 1. The center, of course, is at 3, comma negative 3. And then I need my ABC values. So A is whatever's with the leading term, the non-negative term, and the y part is non-negative this time. So A is going to be 4, B will be 5, and then C is the square root of the sum of those two. 1 to 41, and then get an approximation for that. 1 square root of 6.4ish. 4ish, so where are we? 1, 2, 3, negative 1, 2, 3. It's right here. The orientation, the branches are going to be on the top and bottom there. So I'm going to go up 3. Up 4. 1, 2, 3, 4. And down 4. 1, 2, 3, 4 for the bottom of the box. And then left and right by 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, here's my box then. And then get your asymptotes. I don't know if they're going to ask for the equations. We'll get there. And then the branches like this, and then the foci are out here, down 6.4, so right there, like this. Okay. Okay, so let's see which one it is. It's not the first one. It's not the second one. It's not the third one. So it must be the fourth one. Okay, so D. Check answer. The foci. So you have formulas for all this. The foci will be at moving up and down, so 3 comma negative 3 plus or minus root 41. Okay. So getting back here to this thing. Type ordered pairs. So 3 comma negative 3 plus backslash square root of 41 comma 3 comma negative 3 minus backslash square root of 41. Let's hope it doesn't freak out over that parenthesis. Nope. And oh, it wants the asymptotes as well. So you have the equation of the asymptotes on your formula sheet. In this form, it's rise over run, so a over b is your slope, 4 over 5. And it'll be either plus or minus positive version or a negative version. So it'll be y equals 4/5 times x minus the x coordinate of the center. So x minus 3, and then plus the y coordinate, so that would be minus 3 then. And then this other guy would be x minus 3 minus 3. Does it want you to simplify? Yeah. So the first guy, 4/5 x minus 12/5 minus 3, which is the same as 15/5. So that's 4x minus 27/5, 4/5 x minus 27/5. This will be negative 4/5 x plus 12/5 minus 15/5, which is negative 4/5 x minus 3/5. I'll try to avoid problems where you have to give the asymptotes, but every once in a while one slips by me, so just be prepared to do it, but hopefully you won't. So prepare for the worst. How does that go? Expect the, I don't know. All right, so the one with the positive slope is 4/5 x minus 27/5, and then the one with the negative slope is negative 4/5 x minus 3/5. Okay. And check answer. Oops, must have screwed that up somehow. Equation with the positive slope. Just one second, let me look back here and see what I did. Minus 3/5 x minus 12 minus 15 minus 27 4/5 x plus 12/5 minus 15/5 is minus 3/5 and 4/5 x. I did a over b, right? Go up a and then right by b. It's not being happy about it. I got 27/5 and 3/5. Well, I forgot to put the y equals in there. That's what it is. Sorry. Y equals. Answer. Yeah, so I'll try to avoid those, but like I said, every once in a while one slips by me. And okay, so that's the hyperbolas, and then 9.3 parabolas. 3. So I just want you to be able to, plot the simple ones, 35 to 41. Scooch on over. Let's also do this one in WebAssign, see what kind of curveballs they have to throw at us. Yeah, so homework, and then we want to go on 9.3. And in particular, yeah, 35 to 41. Let's see. What is this? 27? No. 19. Yes, so this is problem 37. That'll work. All right. I hate it when the computer tries to help you out. You know, I'll help you out. I'll put this here and that there. Now I end up having to readjust everything. Okay, so 37 is x plus 1 squared equals negative 12 times y minus 3. Okay, so the vertex is easy. Just kind of read that off. It'll be negative 1, comma 3. You can tell the orientation because x is squared. It's happy face or sad face, depending on the p-value. To get the p-value, you set negative 12, this thing in front of the y minus 3, equal to 4p and solve for p. Okay, so that's kind of like your ABC thing that you need from the parabolas, or from the hyperbolas and the ellipses. Okay, so the p-value is negative, so it's going to be a sad face. And then we can go ahead and get the focus. So to get to the focus, you need to move from the vertex downwards 3. So the focus will be negative 1, and you're moving on the y-axis, the up and down direction, by 3. So you're moving down 3. So it'll be at f of negative 1 comma 0. And then the directrix, you're going to have to move up by 3. And the equation of the directrix in this form will be y equals, right? So y equals 3, and then I have to move up 3. Okay, so that'll be 6, y equals 6. Okay, so let's go in and see what they want. The vertex is negative 1, 3. 3. Whoops, I don't want to do that. The focus is negative 1, 0. And the directrix y equals 6. And then they want you to graph it. Use the tool to graph it. Okay, so we need one of these characters. And vertex negative 1, 3. So negative 1 and then 1, 2, 3. And it's a sad face. You need, you can use the lattice rectum if you want. So the focus is at, so getting back over to my work. Focus is at, if you draw it, what do we got? Negative 1, 3. Negative 1, 1, 2, 3. It's a sad face. The focus is at negative 1, 0. Okay. And then the lattice is 12, so you go back and forth by 6. So 1, 2, 3, 4, 5, 6. In other words, this point is on the graph at, what is it? 1, 2, 3, 4, 5, comma 0. Okay, so 1, 2, 3, 4, 5, comma 0. Save, and check answer. Yay. If you don't like that, you can always just get an intercept. Say just get the x or the y intercept. So working back here with the x plus 1 squared equals negative 12 times y minus 3. For the x-intercept, actually it's probably better to get the y-intercept, but the x-intercept, either one. For the x-intercept, get y to equal 0. Right, and then you'll have, the problem with this way is you have to use square root property or something. So this will be negative 12 times negative 3. X plus 1 squared is 36. And then the square root property says x plus 1. equal plus or minus square root of 36, which is plus or minus 6. So x equals -1 plus 6, which is the 5 that I plotted, or x equals -1 minus 6, which is -7. So you would have 2 points you could use. 5, 0, which is the one I use from the lattice anyways, and then -7, 0. I think in my notes I said the lattice was kind of optional, but now looking at the program, you're going to have to get some other point, you know. So you get the x-intercept, the y-intercept, and you basically just do that the same way we did it for parabolas. Okay. So hopefully that's not too far, a bridge too far for us. Okay, so the last section then is chapter 10. I'm thinking 10.1. I'm not going to put any of the summations on there. I mean, let me backtrack that. When it comes to arithmetic sums, I'm not going to be worried about the sum of the first n terms. There will be summation problems on the test, okay? You have to know how to do factorials, and you have to know how to expand and condense sums. In other words, the summation notation is on there. It's just in 10.2 and 10.3, I am only going to care about the non-recursive, the general term formulas for the, and those are on your formula sheet. So this would be a sub 1 plus n minus 1 times d, and then this formula, a sub n equals a sub 1 times r to the n minus 1. It's just problems like that. I'm not going to put the s sub n problems on there. Like for arithmetic, it'd be n over 2 times a sub 1 plus a sub n. No, I mean, we're not going to worry about those kind. Okay. Okay, so let's take a look. There's a lot of stuff in 10.1, really, but I don't know. Let's dive in here and see what we got. So, not like that. 23 to 53. So, oh my God. So this would be fair game. So number 25, just simplifying a factorial. So here we got 14 factorial all over 2 factorial times 12 factorial. You could do it brute force and expand this, but what I've kind of mentioned in my videos is to use a recursive definition, right? So 14 factorial is the same as 14 times 13 times 12 factorial, and then you see there's a 12 factorial in the denominator that you can remove from top and bottom. So you'd end up with 14 times 13 all over 2 factorial. 2 factorial is 2 times 1, which is 2. Okay, and then you could say 14 over 2 is the same as 7 over 1, and then 7 times 13 is your answer. 1, 2, 7, 91. Okay. Let's get another one. So this is 27. It's more of an abstract version of that problem. So 5n plus 1 factorial all over 5n factorial. So, just like before, you can rewrite 5n plus 1 factorial using the recursive definition. So 5n plus 1 factorial is 5n plus 1 times 5n plus 1 minus 1, which is 5n factorial. Then clearly, those 5n factorials cancel, and you just get 5n plus 1. Okay, let's not go through all of these. Let's skip ahead to the summation types. So it was 14. Whoops, I went backwards. Sorry. 21. Sure. Okay, so is that in my set? Yeah, 23 to 53. So this is problem 41. I just want to expand it and then add it all up. Okay. So this is a sum from I equals 2 to 6 of I factorial all over I minus 2 factorial. Okay, so in the beginning you're literally just plugging those numbers in to the I formula. Okay, so you're starting at 2, and then you're going to etc. Okay. So this will equal, starting at I equals 2, 2 factorial all over 2 minus 2 factorial, and then plus I equals 3, so 3 factorial all over 3 minus 2 factorial, and plus I equals 4, 4 factorial all over 4 minus 2 factorial, and then I equals 5 factorial all over 5 minus 2 factorial, and then I equals 6, 6 factorial all over 6 minus 2 factorial. Okay. And then simplify all this jazz. So it's 2 factorial all over 0 factorial, plus 3 factorial all over 1 factorial, plus 4 factorial all over 2 factorial, 5 factorial all over 3 factorial, plus 6 factorial all over 4 factorial. 2 factorial is 2, 0 factorial is 1, 2 divided by 1 is 2. 3 factorial is 3 times 2 times 1 is 6. 1 factorial is 1, so it's just 6. And then for these guys, you could rewrite them recursively and then simplify. All right, so you get 8, 2 plus 6 is 8, plus 2's are gone, that would be 12, plus the 3 factorials are gone, that would be 20, plus the 4 factorials are gone, that would be 30. Okay. So this is 20, plus 20 is 40, 70. And for some reason, my computer is freaking out on me. It's just too much. I can't handle it. 70. Yay. All right. One of these where you have to kind of figure out the summation notation. You can almost do this without any work. It looks like it's going from 1 to 15, and then the formula should be I cubed. I cubed. Okay. So you have to be able to condense them like that. Let's move on to 10.2 then. 10.2. We're looking at problems like 15 to 33. So basically you have to form the general term formula, which you have in your notes, and then use that to figure out the particular term of a sequence. So let's look at number, I don't know, number 23 maybe. Okay, so in this case they're giving us a bunch of terms. Oh, let's not look at 23. Let's look at 25. So they give us 7, 3, -1, -5, dot, dot, dot. And they want you to find a sub n and the nth term formula, and then find a sub 20. Find a sub n and then a sub 20. Okay. So to find a sub n, I need a sub 1. A sub 1 is 7. And then I need the d value, the common difference. So in this case, it's 3 minus 7. Which is -4. So my a sub n should be 7 plus n minus 1 times -4. And simplify that. 4n plus 4. So a sub n is -4n plus 11. And then find a sub 20. So you just plug 20 into that formula. This would be -80 plus 11, which is -69. Okay. So problems like that. Let's look at 10.3 then. And then these problems, I'm looking for 9 to 23. So basically, the same type of problems, you have to find a sub n, and a sub n in these problems is a sub 1, r to the n minus 1. And then you have to use it to like find a sub 7 or a sub 20 or whatever. So let's look at number, I don't know, 23. And we have the sequence 0.0004, -0.004, 0.04, -0.4, on and on. Okay, they want a sub n and they want a sub 7. Find a sub n, find a sub 7. So we need a sub 1. That's clearly 0.0004. And then we need r. R is the ratio of two consecutive values. So zip negative. Let's use these two values. That'd be easier on our brains. 0.4 and 0.04. That's the same as 4/10 divided by 4/100ths, which is the same as 4/10 times 100/4, which is the same as -10. Okay, so our a sub n formula is 0.0004 times -10 to the n, and then a sub 7 will be 0.0004 times -10 to the 7th, and in calculator terms, what will that be? 0.0004 times -10. Oh, great. I hate this calculator. 0.0004 times parentheses -10 parentheses to the 7th is 4,000. Okay, so yay, and that'll be about it. I probably, it seems after I go through the review, it seems like I got a lot on there. So expect about 30 questions. Okay, don't expect literally everything like this review, but 30 questions long. And any of these types of questions are fair game. I'm going to go straight up right now and write out the final based off of this review. And you know, next week I'll sort of introduce you to this review if you hadn't already looked at it. I'll go over some problems again, and I'll have a. Okay, I guess that's about it. Okay, so thank you for watching, and we will see you next time.